Hi guys, happy Friday. Apologies again that I'm not there, but I should be on Monday, and we'll get back to where we were and take off from where we leave off today. So we're still working through geometry, and a reminder that on Thursday you'll have a test, but this is the last little bit that we're going to do today, and then on Monday we'll go over all the main points of geometry, and I'm sure you'll all do really well. So what I gave you for today was these questions here, 24.5 questions 2, 4, 5 and 6, and it's all about the circle. So we'll have a quick look through some of them. Now what I've done is I've put the solutions out here on the right hand side. So we've questions 2, 4, 5 and 6, so you can have a look through and correct your own homework now in a moment. But I'll just have a look at a couple of them, just question 2 in particular, just to see what all this is about, because all this is about the circle, and it's all about this. If you draw any line or make any triangle within a semicircle, you always get a 90-degree angle. That's the key message here. So I know you had words like radius and diameter and chord and circumference and things like that, but the main point is looking at triangles inside circles here, and that's what this was getting at. It also, you'll see words like use your protractor, use your compass, and that's why I was saying the importance of always having 1, your calculator, and 2, your math set, which you would have found that you needed for these. It's important to have those with you. Quick look at question 2, because after that they're all pretty much the same idea. So what we're going to do, if you have the circle there, now it says draw a circle, but they've given us one. Label the diameter of the circle as shown. We have A and B. On your circle, mark a point C above the diameter A and B. So all they want you to do there is mark a point C anywhere. I could put the point C there, or there, or there, or there, or wherever I want. So if we say, I'll pick the one nearest the A, right? So it doesn't matter. You're correct no matter where you put it. So I've put the point C there. And if I pick a line then, and what I'm going to do, draw the triangle ABC. So I'm going to draw a line from A, and draw a line from A to C. It's a really badly drawn line. I tried to use the shape function, it didn't work. I'm going to try draw a line from, draw a line from C to B then as well. So there's my line from A to C, and there's my line from C to B. Sorry, the straight line thing wasn't working. But there we have as straight a line as I can get. And the point we're trying to make is that wherever I draw that line, wherever I say the point C is, this angle in here is always 90 degrees. So they say there in the question, use your protractor to find the angle ACB. Now remember, when we find angles, it's always A, C, B. So we're always talking about the middle one, which is what's at the angle C, and that's going to be 90 degrees. Anywhere on the same circle, mark the point E. So it could be any of those orange dots that I draw, or I could decide to do it down here. I could call that E. It doesn't make any difference. So I could call, if we say that one of the ones I did at the top was point E. So there's an E there. I'm calling this one now point E. But I could do it down the bottom if I want. And I'm going to draw another triangle. So I'm going to start from here, go to E, and go all the way over as far as E. So I've just drawn another triangle within the same circle. And if I use my protractor to find the angle in here, that's also going to be 90 degrees. If I decided that actually I wasn't going to use that point, I was going to use this point down here, and I decided to draw my triangle like this, doesn't matter, that angle in there is always going to be 90 degrees. So all triangles within a circle drawn from the diameter are going to be 90 degrees. That's why it says there again, you can see it, use the protractor to find the angle AEB. So again, we're looking at either the E there or the E there. last part of the question, what do you notice about the angle ACB or the angle AEB? Well, they're all going to be 90 degrees. So we have 90 degrees there in all three of those triangles that I've drawn. Right, one more. We get into the last question that we're asked there. Find the length of the diameter of any given circle in each of the following diagrams. Always the center of the circle in each case. Okay, so what they're going to trick us here and make us think back to last week's lesson when we were dealing with Pythagoras. So what they're saying there is that here is our hypotenuse. So remember, the longest line is always the hypotenuse. And the line opposite the 90 degrees, and you know that it has to be 90 degrees because it's drawn using the diameter. So that's going to be our hypotenuse there, and that's going to be our hypotenuse in this one. So what we're going to do for both of these, for A and B, so I'll do A out for you, is we're going to use Pythagoras' theorem to find the length of this line here. And the way you do it, well, we don't know what the hypotenuse is in this one, so we're going to set, we call it, what do you want to call it? We'll call it H, call it X, call it James, call it whatever you want. And what we're going to have is the hypotenuse squared is equal to one side squared plus another side squared. And you can work that out then. So 8 squared is going to, so H squared is going to be equal to 8 squared, which is 64, plus 6 squared, which is 36. So H squared is going to be equal to 100. And we don't want to know what H squared is. We want to know what H is. So to go from H squared to H, you have H is equal to the square root of 100. So H is equal to 10. So we now know that the length of that line there is going to be equal to 10. And you do exactly the same for the other one. So you're going to have H squared is equal to 10 squared plus 24 squared. Okay, and remember, this is all saved for you. And if you go into the OneNote, this will be there for you to take a look at. And this video is also saved on YouTube if you fancy looking back over it. So that's what we're going to do for the first 10-15 minutes. What you can do is look back over your homework, fill in any ones you couldn't do, and correct your work. And the solutions to that are here in the OneNote. So the teacher can pause the video and you can go through the solutions to those questions. Our addition today then is these theorems, and you've probably heard that word. I guarantee if you ask people at home about theorems, they'll shake in their boots, but they're not as bad as they're made out to be. Problem with theorems is that there's a lot of maths lingo in them. You come across these words like a proposition and a proof and an axiom and a theorem and a corollary and a converse of a theorem and so on. So what I will go through those with you individually next week. It's like it's like in science, the way you have definitions and you got to learn them and know what they mean. It's the same in maths. But for today, what we're going to do is we're going to go down and take a look at theorems and proofs and things like that. So if you have, for example, in question number 2, and I'm not giving you question 2 to do, but if we have question number 2 here, it's saying there that P and Q are two parallel lines. You can see there's P, there's Q, and you know they're parallel, and those little arrows in the middle lines tell you that they are parallel. Angles 1, 2, and 3 are shown. So they're showing you angles, and you remember now from earlier on, a couple of weeks ago, we were talking about alternate angles and corresponding angles. So keep that in the back of the mind when you're going through these. And what they say is that 1, 2, and 3 are proof that angle 1 is the same as the angle 3. So they want you to show that angle 1 is the same as angle 3. Prove it by filling in the boxes in the following table. So if we say, right, well, from our knowledge, we know that angle 1, so the size of angle 1, here it is here, is the same as the size of what angle? Okay, so we know that angle 1 is the same as angle number 3 because they're corresponding angles. So because they're corresponding angles, what we fill in here is the angle 3. Angle number 2 is the same. Now, bear in mind, these are vertically opposite angles. It's also going to be the same as angle number 3. Therefore, the angle number 1 has to be the same as the angle number 3. Because what type of angles, now someone will know this, what type of angles are 1 and 3? They're not corresponding ones, because remember they're not on the same side, they're not vertically opposite, they are alternate angles. So that's what all this is about, and all the lingo above that we'll be going through next week, that's what it's all about. It's just a way to show that something is true. So we know that 1 and 3 are same because they're alternate angles, but it's just evidence to back up why angle 1 is the same as angle number 3. And I have a couple of questions for you to tap away at there. So after you've finished your homework's all corrected and you've had a read through the proof, here it is here, over here, there we are there. So here's your classwork for the rest of today's lesson. So you can see it all, there we go. Have a read through those theorem definitions. So they're on the OneNote there for you to have a read through, and we'll be going through them again one by one on Monday. And then in exercise 24.6, I've highlighted a couple of them for you. It's Friday, so I won't give you homework for the weekend. So you're going to do as many of those highlighted questions that you can do in the hour, so within the class time. And you don't have homework, but maybe have a look at some at some of your some of the questions from the past in preparation for your test next Thursday. What I would advise is if you go out here into this screen and you're in geometry, you have geometry 1, and at the bottom of geometry 1 you have the final exercise which goes through the whole topic. In the bottom of geometry 2 you have the same, there's the revision exercise down the bottom, all done out for you, nice, a couple of questions for you to try, and the same at the bottom of geometry 3. So we're pretty much at the bottom of it now. So above the exercise you're working on today, or below, sorry, you have the revision exercise, which goes through everything that we've done. And this is what we'll be working on Monday, kind of going through the revision to make sure everyone is ready and can remember the stuff they did a few weeks ago for the geometry test. So going through all the different, your parallelograms, your quadrilaterals, your rhombus, going into the different types of angles, and looking at the distance between here being the same as the distance here, and naming angles, your obtuse and your acute, and Pythagoras theorem and so on. So that's what I would suggest you do between now and Monday to get a head start on the revision that we'll be doing in class to prepare for the test on Thursday. So today, work through the highlighted questions. You can see them there in exercise 24.6. And then if you're finished, you can move on to the revision exercise. And for homework, it's just your own study. And I'd suggest using the revision exercise to prepare for the test on Thursday. Have a great weekend, everyone, and I will see you back in class on Monday.